take a moment before we begin question letter D to ensure that you have the right y-coordinates from the graph, either by looking at the answer key or by looking at the table that you see on the screen here, which indicates the y-coordinates that I found in the time between the last video and this one. Now those values definitely don't match the values in letter B, and I didn't expect them to. The values that we got in letter C were from doing y-coordinates, and the values that we got in letter B were from doing areas. So those are meant to be two very different things, which I'll highlight in two very different colors so that we can see that those are different ideas. But those different ideas, area versus y-coordinates, is going to be a big important feature of this section. So just making sure we understand why we did each table differently is a big idea that I do want to make sure that you're continuing to circle back to. And if it still doesn't make sense, go back and rewatch or go back and rethink through that table again to ensure that you understand why we did it differently, to ensure that you understand the relationship between big F prime and big F, or big F prime and little f. There are a lot of things going on here that I want to make sure that we understand the interplay between, because it's that interplay that's going to help us better suss out the rest of these questions. Now in question letter D it says, recall that we can analyze when big F increases or decreases. Increasing and decreasing were words that I used on page 10. So if you've watched that series of videos somewhat recently and practiced a little bit on page 10, you might recall seeing the words increasing and decreasing as a reminder of a line chart problem. Increasing and decreasing are words associated with the first derivative. So if I want to find out where big F is increasing or decreasing, that really means I want to make a line chart of big F. So I want to make sure that I understand how big F can increase or decrease. Now, the big F itself is not going to tell me increasing or decreasing. To know if I'm increasing or decreasing, I need to know about big F prime. So if I need to analyze a line chart of big F prime, that means I need to ask myself, what do I know about big F prime? We just talked about big F prime in question letter C. So remember how big F prime was the original thing that I asked myself to think about when I made this table? Big F prime is these table values. More specifically, big F prime is little f. Big F prime is the y-coordinates. So I'm going to make a line chart of these y-coordinates and I'm going to analyze that to see if I can figure out what's going on with increasing or decreasing. So I'm making a line chart here, and I'm using my big F prime values to help me figure it out. Now again, if your head is swimming with connections, you can think of big F prime as little f, if that's less confusing. Big F prime was the y-coordinates that I got from the graph. Big F prime was the y-coordinate table that I found in part C. So I'm highlighting all of this in yellow to go back to the idea that big F prime is the y-coordinates. Big F prime is the same as little f. Little f was the same as y-coordinates, so it's all kind of a big equivalence. Now, let's think about analyzing these y-coordinates. We've never really done a line chart with a table of values before, but it works the same way as line charts with everything else. First, let's establish some boundaries. Our table goes from 0 to 8. So our line chart needs to go from 0 to 8. A line chart next needs critical values. It needs zeros. So I'm going to look for where my table has zeros. It looks like I have a 0 here at 3, another 0 here at 5, and another here 0 at 6.5. So I'm going to make in my line chart a tick mark at 3 with a 0, a tick mark at 5 with a 0, obviously not drawn to scale, sorry about that. If you're a little bit type A, I have failed you. And then 6.5 with a 0. So now I need to put pluses and minuses. So I'm going to do some test points. The beauty of test points on a table is you don't really have to plug anything in because you don't have a function to test. You're just looking at the numbers themselves on the table from 0 to 3. All of these are positive numbers, thus a plus sign in that section of the line chart. The numbers between 3 and 5, it's not like you have too many choices to look at, must be negative. The numbers between 5 and 6.5, again, you don't have much to look at there, are positive. And the numbers between 6.5 and 8, again, not much of a choice, are negative. So, if we think about this then, as we think about every line chart that we've ever done in the history of calculus, let's think about what we need to know. Something is increasing when the line chart, or the first derivative, is positive. So I see a positive section and a positive section, which tells me that big F must be increasing in those two intervals. It increases from 0 to 3 and from 5 to 6.5. And we know that because that's exactly what the line chart is meant to tell us. Wherever the line chart is positive, that's telling us where big F is increasing. Likewise, if I want to know where big F is decreasing, I'll look at the negative parts of the line chart from 3 to 5 and from 6.5 to 8. So I would say that big F decreases on those two intervals from 3 to 5 in union with 6.5 to 8. Now, if that seems like pretty standard line chart stuff, that's good. That's definitely what's supposed to happen. The difference is we've never really done a line chart with a table before, but we didn't really have a choice. It's not like we could do an equation and do a derivative and set the derivative equal to 0, which is usually how we do line charts, and we just didn't have a derivative function to work with. The derivative was really just an interpretation of the graph. So it's this flexibility of thinking that we actually are kind of focused on here. It's this flexibility of thinking that's making these problems different. The idea that we had to take a derivative by taking a derivative of an integral is a pretty big jump for us. Derivative used to mean power rule, and now all of a sudden derivatives are like fundamental theorem of calculus. That's a big step. But the theme of this unit is just adapting to what we know. If I had to take a derivative and all I knew was a weird integral symbol, the derivative of the integral canceled out. So taking the derivative was really just akin to saying analyze little f. And I analyzed little f, I analyzed the y-coordinates of the graph gave me all the information I needed, and I was able to make my line chart with that information. So here's my last challenge for you on this page before you move to the next one. Try question letter E. What do your answers to this line chart problem have to do with snow? Remember, this was a context question about snowfall? What do these answers have to do with snow? See if you can put it in your own words. If that troubles you because you know that that's not your strong suit, if you're good at doing math, but as soon as words come in, it fails you, then don't worry too much. In the next video, I'll give you my interpretation of the snow accumulation. But see if you can think about it. What do these answers have to do with snow? Think about units, think about anything that could help, but try to put it in your own words.